While Vortex mixers are invaluable tools in laboratories, they do have limitations that users should consider. Understanding these disadvantages can help researchers and scientists make informed choices about their equipment needs. Disadvantages of Vortex mixers: limited volume handling. Vortex mixers are most effective for mixing small volumes of liquid or suspensions. Larger volumes may not mix thoroughly, leading to uneven distribution of components. Potential for sample damage. High-speed mixing can cause mechanical stress on sensitive samples, potentially damaging cells or disrupting fragile structures. This can affect the accuracy of experimental results. Noise level. Some Vortex mixers produce significant noise during operation, which might be disruptive in quiet laboratory environments. Heat generation. Continuous high-speed mixing can generate heat, affecting temperature-sensitive samples. Users must monitor the temperature to avoid denaturing proteins or altering chemical reactions. Maintenance requirements. Regular maintenance is necessary to keep the mixer functioning optimally. Failure to maintain the device can lead to reduced performance and shortened lifespan. Cost. Advanced Vortex mixers with digital controls and additional features can be expensive, especially for budget-conscious laboratories. Complexity. For certain samples, mixing certain types of samples, such as those containing large particles or very viscous liquids, can be challenging and may require specialized attachments or techniques. Conclusion. Despite these limitations, Vortex mixers remain valuable tools in many laboratory settings. Researchers should consider the specific needs of their projects when selecting a Vortex mixer to ensure compatibility and optimal performance. To learn more about Vortex mixers and related products, feel free to visit my homepage and contact me via email. I will respond within 24 hours.